So it would have been great if 2020 was the year that Intel came roaring back with a slate of killer high-performance processors, ones so good that AMD would have to slash prices in order to keep up with them. But 2020 was not the year for that. This past spring saw the release of Intel's 10th gen Comet Lake desktop processors with the flagship 10-core i9-10900K. We tested out some of these chips and they're fine. Honestly, they're really fine, but all of them are maybe a little bit too expensive for the performance you get. Comet Lake is the maybe fifth iteration of Intel's 14nm process? I'm not sure. I have completely lost track because they stopped adding pluses after 14+++, so who can say? When we tested the 10900K, it was plenty fast, but it ran super hot and sucked down more than 200 watts of power. Intel's in a bit of a rough spot here. Their long-awaited 10nm manufacturing process, which promises better performance and less power usage, still seems to be barely off the ground. So they're stuck just adding more cores to the same tweaked design we've seen for half a decade now. The reality is, at most of the higher end, there is an AMD chip that probably runs a little bit faster, uses less power, and again, this still kind of blows my mind, probably costs less than a lot of Intel's competing products. Things did get a lot more interesting at the low end, though. With these 10th gen processors, Intel is finally offering hyper-threading, essentially processor multitasking, all the way down to its cheapest CPUs. You can get an i3-10300 chip that's about the equivalent of their flagship i7-6700K from a few years ago for just $175. And as we found in our testing, paired with a decent GPU, that is still plenty fast for most gaming. PCI Express 4.0 is expected on Intel's next chips called Rocket Lake. Confusingly, Intel's 10th generation chips on mobile are entirely different. While they actually premiered in 2019, this year finally saw the wide release of chips based on their Ice Lake design, like the i7-1065G7, which is made with that long-awaited 10nm process. And they're fine. Again, they're kind of just fine. They're pretty efficient, and the integrated Iris Pro GPU is a big leap forward for Intel's graphics capabilities, but they're kind of held back by slow clock speeds, and so far the 10nm chips just haven't really made a splash. We also saw the release of the first chips for Intel's follow-up to Ice Lake, Tiger Lake, which is built on an improved 10nm process and features a redesigned core architecture. Tiger Lake, or 11th gen chips, are starting to show up in new laptops like the Dell Inspiron and XPS 13, but so far we've only been able to test the higher-end i7-1185G7 in a prototype machine. And again, who is coming up with these names? Tiger Lake bumps up cache sizes and does bring some improvements in clock speeds, but the biggest changes are in Intel's integrated GPU. Tiger Lake features Intel's brand new redesigned Xe graphics architecture, and we found it was good enough to get around 50 or 60 frames per second at 1080 resolution in medium settings in Overwatch, which is not bad for an integrated GPU. These chips should offer some boosts in performance for the ultra-portable segment, but for serious workloads like rendering and video editing, with only 4 cores, these Tiger Lake chips seem to be struggling to keep up with AMD's 4000 series chips, which have been out for a year and were actually based on even older Zen 2 technology. Intel did also launch its new Lakefield chips based on its Foveros design, which takes the various chip components and stacks them vertically. Designed for low-power devices like tablets and ultra-portables, the first Lakefield devices we've seen are actually pretty impressive, delivering decent performance while only sipping a few watts of power. In our editor Sherlin's recent testing, the Lakefield-powered ThinkPad Fold X1 actually bested an iPad Pro in a video playback battery life test. The Lakefield design, with its vertically stacked chips and a smartphone-esque mix of high-end low-power cores, is actually a pretty big deal. Intel has essentially taken a chiplet manufactured at 10 nanometers and containing 5 processor cores, the graphics and other logic, and glued it on top of a 22 nanometer chiplet containing things like the USB and storage controllers. This is akin to AMD's use of a 7 nanometer processor chiplet and a 14 nanometer input-output chiplet, but it's new from Intel, and the vertical stacking design is unique. Lakefield has some big potential advantages in areas like power power consumption and memory access. And though the current chips max out at a mere 7 watts of power, it may give us a clue for what Intel has planned in the future. We're also getting more info about Rocket Lake, Intel's next desktop chips, which take the improved core design from Tiger Lake on mobile and backports it to some sort of 14 nanometer quintuple plus process. Rocket Lake should finally add support for PCI Express 4.0, but it seems like it'll max out at 8 cores, which means that unless those cores come with a serious improvement in performance or speed, it's going to face some stiff competition. At this point, it seems like we won't see a high-performance 10 nanometer desktop chip from Intel until 2022, when their Alder Lake platform is set to launch, which should feature an entirely redesigned architecture along with maybe a mobile-esque mix of high and low-powered cores.